Alright guys, welcome to lesson 7 of unit 2. We're going to talk about inverses. This is going to take 2 lessons, but this is the part 1 and we'll get to part 2 next time. Today we're going to talk about what an inverse function is, first of all. Then we're going to learn how you can write the equation of an inverse function. And then the third thing is we're going to look at how to interpret what inverse functions mean in the context of a word problem. Okay, so without any further ado, let's begin. So before we begin, I want you guys to pause the video here, take like a moment, and just kind of ponder the answer to these 2 questions here. And then when you unpause it, we'll discuss it. So it says here a square has side length of 9 inches. What's its perimeter? Well, as you guys know, a square has 4 equal sides. So if all the sides are 9, and you have to know what perimeter is, of course. Perimeter is adding all the sides up. Basically what it is it's 9 multiplied by 4, and you get 36. So the second one here, we have a square has a perimeter of 20 feet. How long is each side? Well, in this case, I don't know how long the sides are. But I do know that if I add them all up, I get 20. Another way to write that is like this. And then we can divide. Now some of you guys probably didn't, most of you guys probably didn't even do all that work. You probably just thought, okay, well just 20 divided by 4. And you're right. So we have this, and we have this. So what I want you guys to notice then is that we can write it like this. We could say to find the perimeter, you could just take the side lengths of your square, S, and multiply it by 4. And that will tell you the perimeter. Or, in the similar way, you could take the perimeter of your square and divide it by 4 to find the sides. These 2 equations here, which I'll circle in red, 4s equals p and s equals p over 4, you guys kind of see how they're really just kind of the same thing. It's just that they're doing opposite things. The first one here, 4 times s, gives you the perimeter. The second one down here, p divided by 4, gives you the sides. But they go together, right? Well, these 2 functions are examples of what we would call an inverse functions. They're opposites of each other, okay? They go together, but yet they do opposite things. So, we kind of already talked about this, so I'll skip that. Now, instead of using p and s, let's go ahead and use x and y. So, if I say y equals 4x and y equals 1/4 x, we're gonna complete these tables here. All right. So if x equals 1, so in other words, I'm going to plug 1 in for x here. What does y come out to be? It's 4, right? What if I plug in 3? 12. What if I plug in 9? 36. Okay. Let's take this function over here. What if I plug in 4? What's 1/4 times 4? Well, put the 4 over 1, right? And then multiply straight across, you get 4 over 4, which reduces to 1. What if I were to plug in 12? One-fourth times 12. Multiply straight across and reduce, you get 3. What if I plugged in 36? You would get 9. Now I want you guys to take a moment here and compare these 2 tables. Look at this table and this table. They go together, but they're opposites, right? They have all the same number pairs, like 1 and 4, 4 and 1, 3 and 12, 12 and 3, 9 and 36, 36 and 9. The only difference is the x's and y's are switched. That's what an inverse function is. So they are two different functions. These are two different equations, okay? But they have a very special relationship. The inputs of this function are the outputs of this function. And the opposite is true as well. The outputs of this function are the inputs of this function. Okay? So that's what makes two functions an inverse. Another way you can kind of tell is by looking at the equations. This is x being multiplied by 4, and this is x being divided by 4. So opposite operations results in opposite domains and ranges, which makes inverses. So that's what an inverse function is. So here's a formal definition. Two functions f and g are inverses if f of s equals p implies that g of p equals s. In other words, the inputs and outputs are all reversed. And that would be true for anything you decide to plug in. Okay? Sometimes two functions, it might be the case that this happens for two random functions, but it doesn't always happen with everything you plug in, only a certain pair of numbers. But for inverses, it always works. No matter what number you plug in, it always comes out to be flipped like that. Okay? So why do we study inverses in mathematics? Well, in mathematics, we kind of showed you it earlier here when we did the perimeter of a square problem. We have p equals 4s, and then we have s equals p over 4. They'll both give you the same pairs of numbers, just in opposite orders. But the point is that this one is easier if you're just trying to find the perimeter. This one's easier if you're trying to find the sides. So the reason we like inverses is because, well, it helps us to find one variable easier than the other. Okay, that's one reason why. But also mathematicians are just kind of nerdy, and when they started comparing inverse functions, they found a lot of really interesting relationships and thought, hey, well, we can study this, can't we? So if the function g is an inverse of f, then instead of writing g, we could write f inverse of x. Okay? So let me be a little bit more explicit here. If the function g is the inverse of f, then what we can do is we could say that g equals f inverse of x. Or you could also say that f of x is the inverse of g. It doesn't really matter, but this is the symbol that we use to represent inverses. Okay? So if you ever see this symbol, that means that this function is the inverse of g. Okay? It's kind of an unfortunate form of notation because it looks like a power, but it's not. It's just a symbol that they chose to use to represent inverses. All right, so example 1a. Find the inverse of the function. All right, so we got some steps to go here. Now, before I begin, you guys don't need to write this part, but I just want to show you what we're trying to find, okay? Let's say I plug in 2. I get 1, okay? So that's what this function does. This function works so that when I plug in 2, I get 1. Well, what I'm trying to look for is I'm trying to look for a function that's the inverse of f. And here's how the inverse of f will work. Whatever function I find, when I plug in 1, I will get 2. It's the opposite. Instead of plugging in 2 and getting 1, for this one I plug in 1 and get 2. So I'm looking for an actual equation that will do this. Now there's a lot of equations that will do that. But I want an equation that will do that for anything that I decide to plug in for x. Okay? So that's what I want to do. Now, I'm going to give you guys some long steps on how to do this. I would encourage you guys to write them down. All right, so here we go. Step 1. Replace f of x with y. The reason we do that is because the f of x is a symbol that is a little bit clunky. and it makes it difficult to write nice and neat and clean. It makes things confusing looking. So it's just nice if we replace it with just a single letter, okay? It's not entirely necessary, but I would highly advise you do it. It'll help you avoid errors. All right, the next step, this is the real step. This is the magic step here. We're going to switch X and Y. That is the official step that makes this an inverse, because remember, for inverse functions, the x's are the y's and the y's are the x's. So I'm going to put the x here and the y here. And so now, automatically, I just created an inverse. But anytime you are doing, trying to write a function, you want to get the y by itself. And here's the problem with these problems I'm giving you, is that this third step will be different for every problem. You just have to know how to do some algebra. So I want to get the y by itself. So let's take a look at this equation that I have here right now. How would I get y by itself? Well, the first thing I would do in this case is add 5. Will you always add a number? No, it just depends on the equation. But in this case, we start by adding 5. Now what do? Now you would divide by 3. Will I always divide by something there? Nope. It just depends on the equation. You have to know how to get the y by itself. So now this is an acceptable answer here, okay? But it's possible that this answer can be written a little bit differently. You could write it like this also. You could split that numerator up into 2 separate fractions. And instead of writing this like that, you could also write this. So either of those 3 things are acceptable. It doesn't really matter which one you go with. But I'm going to throw on another step, and the last step also is just kind of like, okay, well, you don't really have to do it, but why not? Now we're going to replace the y with the inverse function notation. So here's what I mean by that. I'm going to replace y with f inverse of x, and we have that. Okay, so there's my inverse function. Now, you guys remember in the beginning I took my f of x here, I plugged in 2, and I got 1, right? Now, you don't have to do this, but I'm going to show you that for this function that I just came up with, I should be able to plug in 1 and get 2. Let's see if that works. Okay, so I'm going to plug in 1 for x. If I do that, I get 1/3, because 1/3 times 1 is just 1/3. 1/3 plus 5/3 is 6/3, and 6/3 is 2, just like we thought. Okay, so that's the process you go through. So step 1, replace f of x with y. Step 2, switch the x and y. Step 3, get the y by itself. That will be the one that you have to ponder about. And then step 4, replace the y with f of x. Okay, so let's go ahead and have you guys start trying some of these here. Okay, actually, I'm not going to have you guys do it on your own yet. You can continue to watch me. Let me see, what else did I do? After this, I did, should be another one, I think. Student practice one. Okay, yeah, so we'll treat this one kind of like a little bit of a guided practice. So what I mean by guided practice is I would encourage you guys to try each step on your own. So go ahead and pause the video and try step 1. Okay, so this is what you guys should have written for step 1. You should have replaced the f of x with y. Okay, go ahead and write step 2. Okay, this is what you guys should have gotten for step 2. And by the way, if I'm going too fast, pause the video so you have time to do this. Switch the x and y as the next step. So that would look like this. And now for the fun stuff. You guys got to get y by itself. So pause the video here and try to get y by itself and see what you get. The first thing I would suggest doing is minusing the 4 on both sides. which gives us x minus 4 equals negative 1 over 2y. The next thing I'd recommend doing is multiplying everything by 2. Because 2 on the top cancels 2 on the bottom. Doesn't get rid of the negative though. Now if you want to get rid of the negative, just multiply everything by a negative 1, and that will just change all the signs. So here is my final answer for that step, y equals negative 2x plus 8. Okay, now the last step, go ahead and write the last step. You should have written the following. Negative 2x plus 8 equals f little negative 1 of x. Okay? And there's your inverse function. All right. So I'll let you guys do one now completely on your own from beginning to end. You go ahead and try to solve this equation, or not solve it. Go ahead and try to find the inverse of this function. And by the way, I'm gonna do something a little bit different here, just to mess with you. I'm gonna put a g here. Doesn't really change much, but see if you can figure out what to do with it. All right, go ahead and pause the video. When you're done, you'll see the solution. Okay, the answers are circled over there on the right. You could write it in one of two ways, so I'll explain my way through the problem here. So step 1, replace g of x with y. Step 2, switch the x and y around. And then all of this is step 3 until you get here, where you get the y by itself. And when you get y by itself, you can either write it as 4x plus 4 over 3, or you can write it as two separate fractions. And then replace the y with g with a little negative 1. I forgot to put the negative there. G with a little negative 1 of x. Okay? So that's how you can find the equation of an inverse function. Okay? Now we'll talk about how to interpret that stuff in the context of a word problem. Okay? So, example 2. The population, which is going to be represented by the letter P here, the population of birds on an island is given in thousands by this function here, where T is the number of years. So P represents the population of birds and T represents years. I'm going to write that at the top. P equals population of birds in thousands. And what that means is, like, if I say P equals 1, what that really means is 1,000. Or if I say P equals 2, that means 2,000. And T represents years since 2003. Okay? And we have this function here. And what this function here is telling me is that the population of birds depends on what year we're in after the year 2003. Okay? So, if we have f of t equals p, right? Then when I write the inverse of this, the t and the p switch roles. Over here, the t is the input and the p is the output. But when I do an inverse function, the p is the input and the t is the output. So just some advice as you guys start to do these word problems where you're interpreting stuff. I haven't even started the problem yet, but here's what I'm suggesting you guys do. I'm suggesting you guys do two things. Make sure you know what p and t represent. And then I would write both of those out. F of t equals p, and then I would take the time to write f inverse of p equals t, because they're inverses of each other. And that will help you interpret things a little bit better. Okay, so there we have it. So what does this mean? What does f of 4 equals 1.5 mean? Well, first of all, this is f, right? This isn't f inverse. This is just f. So we're going to look at this. So when you're looking at this, the 4 represents a t-value, and the 1.5 represents a p-value. And so what that means is that there are 1.5 thousand birds 4 years after 2003. Now 4 years after 2003 would be 2007, right? So what you could say is you could say there are 1.5 thousand birds in 2007. Okay? Let's go ahead and take a look at part B. Now for part B, it's not F anymore. Now it's F inverse. And when we have F inverse, the number in parentheses switches roles. So in this case, the number in the parentheses is a p-value, and the output is the t-value. So in this case, we have 4,000 birds 2 years after 2003. So this one is saying that there are 4,000 birds 2 years after 2003, which is 2005. Okay, so what I'm trying to be able to get you guys to do is to understand how, when you look at a statement like this, what the input and output mean. Okay, so up here, for F, the input is time, the output is birds. But for F inverse, the input is birds, the output is time. So take time before you begin the problem to make sure you know what the variables represent. And then also take a minute to write these out. It will help you interpret the answers a little bit better. Okay, so I'm going to clear that out. I'm going to throw one at you guys now. Go ahead and pause the video and see if you guys can interpret these statements. Okay, so at the top I did the interpretation. D is distance, T is time. And then I also wrote F of T equals D, therefore F inverse of D equals T. So when I come down here to part A, since we're looking at an F function, the number in parentheses is a T, the output's a D. And so that means that we've driven 30 miles after 3 hours have gone by. For part B, it's an inverse function, so the number in the parentheses this time represents a D value, whereas the output represents a T. So this means we've driven 3 miles after 0.1 hours, which you could convert into minutes. Just multiply 0.1 times 60, and you'll get 6 minutes. So we went 3 miles in 6 minutes. And there you guys have it. So that might be it. I think we're done for the day. So until next time, we'll see you guys then.